Greeting grade 12. Today we'll be dealing with your physical science paper 1. So we'll be making use of your June examination that was written in different provinces, so that we can actually see how far are we as far as our preparation is concerned. Remember, we'll be writing preparatory examination very soon, so we just want to see and actually revise what we did in term 1 and term 2. So we'll use a series of question papers that have been written this year, and to also see how the examiners are actually asking those questions. So let's jump right into it. This is one of the questions that was written in one of the provinces. So we start with question 2, which are the Newton's laws of motion. So let's look at the scenario that we have. So we have a buggy with a mass of 900 kg and pulls a trailer with a mass of 150 kg over a level road in a westerly direction as shown in the diagram below. The engine of the buggy exerts a force of 8,000 newtons. The frictional force on the buggy is 1,800 newtons, and that of the trailer is 300 newtons. So you have a series of information. You can also highlight the information that you have, and if you forgot the information, please do read the statement again, so that you can actually remember. Then highlight what is very important. We have a mass. So here we have a mass of 900 kgs. It's pulled with a mass of 150 kg. This is another mass. So this one is for the trailer. This one is for the buggy. This is for the buggy, and this is for the trailer. Over a level road surface. So this is very important. It is level. The road is level, so there's no incline. In a westerly direction. Direction is also important. And then, as shown in the diagram, the engine of the buggy exerts a force of 8,000 newtons. Buggy, we have a force of 8,000 newtons. These are the key. We are actually highlighting the key. So we also have a frictional force on the buggy. Let me just also highlight buggy, 1,800, and on the trailer is actually 300 newtons. Good. Now for 2.1, it says state the Newton's second law of motion in words. Please make use of your examination guidelines and write it exactly as it's written there. So we'll be doing, okay, let me just use a different one and the highlighter. Your Newton's law of motion. Remember, this topic was also studied in grade 11. So straight to 2.1. State the Newton's law in motion. Okay. And it states from your examination guideline. When a net force acts on an object, the object itself will accelerate in the direction of the force. And the same acceleration please don't mind my handwriting. The same acceleration is directly proportional to the force. And inversely proportional to the mass of the object. So your examiners will want it as it is. So I'm writing it down because I just want to show you the importance of knowing and using your examination guideline. Because in them awarding marks, if you see this question is actually 2 marks. So there's actually 2 marks that is actually will be given to you. So the first part, this is very important. We need to have a net force that is acting on the object. This is very important. And then they need to also see that the acceleration, the object will accelerate. The object will accelerate in the direction of the motion. So this is also very, very important. Acceleration in the direction of the force. So this is very, very important, in the direction of the force. Where's the force? Yes, good. Then you will get your first mark for that first part. And the second part must also be very, it must mention the acceleration is directly proportional to the force and inversely proportional to the mass of an object. That's when you're going to get your second mark. Hence is 2 marks. So we need to write it as it is. Please study your definitions in all the topics. It's very, very important. They contribute quite a number of marks that might help you to actually pass physical sciences. And then remember Newton's second law, what it's actually stating is that F is equals to ma, because that is acceleration. Hence the first part, that acceleration, the object will accelerate in the direction of the force, and the acceleration is directly proportional to the force. Acceleration is directly proportional to the force. That's what it's saying. So normally when you use proportionality, there's also a constant there. That's what it's actually saying. And then the second part is saying and inversely proportional to the mass, the acceleration. So the mass is what it actually means. So, or we can say acceleration, because if you were to simplify this to make acceleration, the subject of the formula from this side, you'll actually divide both sides by m. Divide both sides by m. So this will divide this, then we have acceleration being equal to F over m. Hence they're saying it's inversely proportional. So when acceleration increases, when the mass increases, acceleration will decrease. That's what it actually means. Direct proportion means that if I increase, you increase. Hope you got that. And then we can move to 2.2, which says draw the free body diagram of all the forces acting on the bucky. So it's very important. On the bucky, because we have a trailer and we have a bucky. So let's take a look at what we have. We have a free body diagram. On the bucky. Good. Let's see what's happening at the bucky there. Just make a dot there. Let's do it like that. So we see that we have an applied force, which was highlighted that side. Also on the diagram is there. This is our applied force. Remember, the direction is going westerly, so it's going in this direction. So that's our applied force. Good. And then because we are on Earth and it's on the surface, on the ground, we'll have our force of gravity. And then we'll have a normal force. And then, because the motion is going aside, there will also be a frictional force, and that's also stated the bucky has a frictional force. So this will be our frictional force. And then because the bucky is attached to the trailer, it will cause tension. So we have your tension. Just try to draw it, yes. And the marks will also guide you how many forces are there. You have 5 marks. So let's see if we can get that 5 marks, okay? This will give you a mark. This will give you a second mark. This will give you another mark. And then you have another mark, and you have another mark. That's your 5 marks. So it will also guide you how many forces are there. So if you have 4 forces, you must know that one of them is actually missing. Go and read the statement again and see what is actually happening. And it's very important for you to get the correct free body diagram, because it's going to help you at a later stage. So this will be your tool to actually solve problems that might also arise. I hope you understand. If you have any questions, please do so. Please do ask them. So that's your 2.2. And then we go to 2.3. It says calculate the acceleration that the system experiences. So this is where your free body diagrams are very, very important. So just to make our life much easier, I'm going to move everything to the right so we can do the free body diagram of the trailer, so that you can actually have all the forces clearly noted. That's just for you. They never said draw the free body diagram. Just to make your life simple, draw yourself a free body diagram also of the trailer to avoid making any mistakes. So I'm going to make a bit of space. Good. Remember, you have the information on that side. So this is for the bakkie, and let's do for the trailer. For our trailer the side, then we have, this is our trailer. We have our normal force. We have our force of gravity, and then we have the tension. It will be in this direction because we are pulling it towards the left hand side. And then the frictional force, which is always opposite to motion. That's your free body diagram, just to assist you. So let me do this. I'll just draw a line here. Good. Might need them somewhere. Good. Let's look at the forces that are on the bakkie. So we'll choose the direction. Just to make your life easier, always take your direction of the motion as positive. So we'll take going to the left hand side westerly as our positive. Just to simplify your calculation, always take your direction of the motion as positive. It's not like when you take it as negative, it will make any difference. It's just going to complicate things for you. But just to, if you can also always do that. Now let's look at the forces that we have. Here's our free body diagram. So will be, because the motion is horizontal, it's moving horizontally, it's not going up or down, it's still on the ground. So your normal force will have the same magnitude as your force of gravity, because it's not on an incline or anything, it's just horizontally. So your force of, because the two horizontal forces which actually balance each other, hence we are not moving up and down. Good. So we have F equals to MA for this side. So we'll only focus on the horizontal forces. Since well, I'll going to the left hand side is positive, we will then say I'm having the applied force by the engine. Going to the left hand side is positive, and then this is this one, and then we will have your frictional force, or you can start with your tension, either way. So let's say tension, it is negative because the tension is opposite to the motion, is negative, and then we have a negative frictional force, which should be equal to MA. And then we can do the substitution already this side. So the applied force, we were told it was 8,000 newtons, minus your tension, we don't know your tension yet, and then we are also given the frictional force at 1,800 newtons. It's equal to the mass of the bakkie. The mass of the bus was actually 900, so we have 900, and then multiply by the acceleration. Then you can simplify this. So you'll get 6,200 and then minus t, which will be equal to 900 multiplied by a. And then we have two unknowns. As we know in mathematics, if you have two unknowns, you need two equations. So it means we need to go and find the other equation. So this is equation number 1. Then let's jump that side. What is actually happening this side? We also sticking to saying going to the left hand side is positive. So this side, you still have f is equal to ma because it's 116. If this acceleration this side will be the same as the acceleration that side, so once they are attached to each other. So like we said, we'll just focus on the horizontal forces. So we start with the tension. Positive minus the frictional force is equal to ma, because these are the only two forces, and this is pointing to the right hand side, so it's negative. Then let's substitute, because we don't know the value of t, so t minus, we were given that the frictional force on the trailer was actually 300. You can also check, it was given the side 300, just to make sure. So we are substituting, so 300 newtons, and it cost, the mass was actually 150, yes, multiplied by the acceleration. So here's our equation number 2. So we're going to solve this simultaneously. You will remember that in mathematics. So you need to make 1 the subject of the formula. So since t is positive, this side is easier for us to just move the 300 to the other side. So we'll transpose this to the other side and it will change the sign. So we'll have t, still equation number 2, being equal to 150a. So I'm just going to do the calculation so that we can see them how we do the calculation. Good. This goes that side, so it's going to be a positive 300. Let's change the sign. So we have our two equations, equation number 2. So this is still our equation number 2. So we're going to substitute. Now I'm going to substitute equation number 2 into equation number 1. Now this is equation number 1, 6,200 minus, what is the t? Here's the t this side. So wherever I see t on the equation number 1, that's how I'm going to put it this side. So I will have, continue using black, 150 a plus 300 being equals to the 900a. Good. Let me just go a bit down for some space. And then we're simplifying. Simple algebra. So we have 6,200. Hope you can see it. Negative multiplied by positive, negative 150a. We're dealing with that bracket. And then this will be a negative 300. Then this will be equals to 900a. And then we're simplifying, collecting the like terms. That's subtracted by that will give us, press your calculator, 5,900. And then we transpose this to come this side. And it will then give us 900a and then plus 150a. Because the sign will change because we have. Good. So this will give us, okay. So if you add them, they will give us 1050a. So simple algebra, we divide both sides. 1050. And our a will simply give us, if you press a calculator, it gives you 5,619, which is 6,2 meters per second squared. The units must be correct. And that's your answer for acceleration. So if the question was to say find the tension, then you can substitute in one of the formulas to say, okay, my tension, take this equation 150 and you multiply by 5,62 and then plus 300, and then it will give you the value of that tension. If the question was to say find the tension, and then it will be newtons. Good. And then please also do state you chose your direction, so acceleration must also have direction. Because it's positive, please don't assume that because you wrote it down the examiner will give you a mark. Please write, because you know your positive is to the left, then you write it. To the left. Good. Just to make sure. And then let's take a look at what is actually happening this side. So go to 2.4. There is a 2.4. So what happened is that the mass of the trailer is now decreased. How will this change the net force and acceleration of the system? Choose from increase, decrease, or remains the same. So this is now, you can relate this to a real life problem. So I'll say what is actually happening is that, let's take this as one system. That's the applied force by the engine, which will remain at 8,000 newtons. And then your normal force and the force of gravity, then your frictional force, total frictional force. So let me just write both of them, two of them. So this is just conceptual understanding, relate them to real life problems. So what is actually happening is that the mass of this object, total mass, would have actually decreased. And how will that affect your frictional force of the trader? Because if the mass decreases, your frictional force in actual sense will also decrease, because it's relative to the motion, how it substances itself to the ground. So you can use that to actually understand the problem. So the net force will mean that the friction that is applied for the trader will not be as big as it was before. So if you look at your net force, it means the forces that are actually opposing the force applied by the engine will actually have decreased. So your F net to the left will actually increase. F net has increased because now the resultant force would have actually increased. So F net will increase. And then we said by definition, acceleration is directly proportional to the net force. So your acceleration is directly proportional to the acceleration. So if the F net has actually increased, it means our acceleration will actually increase. So our answer will just be increased. Yeah, if you have time, you can also use what you actually have been calculating the side to solve it algebraically, but it's gonna take you a very long time. Just substitute any of the masses that are there, and let's see how it's going to help you. But in actual sense, you can just use your real life programs to actually make sense of the whole what is actually happening. I hope you understand that side, this one.